Hope you must have seen a massive fan or pump still spinning even after it's turned off. Now imagine what happens if the motor restarts suddenly while it's still in motion. Bam! A surge of current, mechanical stress, and even potential motor failure. But what if I told you there's a way to smoothly catch that spinning motor and bring it back under control? That's exactly what Flywheel Start, or Catch on the Fly, in a VFD does. Stay with me, and I'll explain why this feature is a lifesaver for motors and how it works. Normally, when a VFD starts a motor, it assumes the motor is at a complete stop. But in many real-world applications, motors don't just stop instantly. They keep on rotating due to inertia, also known as the flywheel effect. Sometimes motors start rotating in reverse direction due to other fan air pressure supplying to a common header like we have in cooler applications in a cement plant. So when you issue a start command to a free spinning motor, it can cause high inrush currents, which can trip the VFD or damage motor windings, sudden torque impact, leading to belt slippage or mechanical wear, and electrical stress, causing unwanted faults and shutdowns. That's why VFDs come with a smart feature called Flywheel Start to detect the motor's actual speed and smoothly take control of it. Flywheel Start is a special startup mode that detects the residual speed of the motor and synchronizes the VFD's output frequency with it before ramping up to full speed. But the question is, how does the VFD know the motor is still spinning? There are very interesting methods to detect free rotation of the motor. It may use one of these two methods. Back-EMF detection is the most common method used. When a motor spins, it acts like a generator, producing a small voltage known as back-EMF, electromotive force. So whenever a start command is issued to the VFD, it temporarily stops output and measures this voltage and frequency to estimate the motor's speed and direction. This you can observe on the VFD console. While the motor is yet not started, and run feedback from the VFD panel is still not available, if free rotation is in reverse direction, you will see negative RPM readings on the VFD console. And if free rotation is in forward direction, readings will be positive. Once the speed is detected, the VFD gradually applies frequency and voltage to smoothly regain control to set point RPM. This process is very much similar to jumping onto a moving treadmill instead of starting from zero. The process of detecting a free spinning motor and catching it takes time. Till then, feedback run to PLC DCS is not available, and it may declare feedback fault and withdraw start command. So feedback run monitor time in PLC DCS needs to be kept appropriately for such applications. Speed feedback from an encoder is an advanced method, but needs to have some speed feedback sensor. Some high-precision applications use encoders to track real-time motor speed. The VFD directly reads this feedback and adjusts its output frequency instantly. This is commonly used in cranes, elevators, and high-torque machines. This method is super accurate, but requires additional hardware or feedback sensor. So most standard VFDs rely on back-EMF detection. Flywheel Start is critical in industries where motors rarely come to a complete stop before restarting. Here are some real-world examples. Industrial fans and blowers, pumps, centrifuges and compressors, elevators and cranes. Most VFDs have a built-in Flywheel Start function that you can enable through parameters like Catch on the Fly or Speed Search. Enable this function in the VFD menu, Detection Sensitivity. Adjusts how aggressively the VFD searches for spinning motion, restart mode. Some VFDs allow smooth ramp-up or immediate frequency synchronization. Each VFD brand may use a slightly different name, but the concept is the same. So next time you see a large industrial motor slowing down but not stopping completely, remember? The Flywheel Start feature in a VFD can prevent electrical and mechanical disasters. It's a must-have in applications with high inertia loads. What do you think? Have you ever used Flywheel Start in a VFD? Let me know in the comments below. If you found this video helpful, hit that like button, subscribe, and stay tuned for more VFD insights. Thanks for watching, and I'll see you in the next video.